Hello, this is Mrs. Bennett, and this is our lesson on systems of inequalities. Now, I'd like you to take a few minutes and pause this video after I give you the directions, but I'd like you to take a few minutes to answer these questions. So the first 5 questions are review questions from earlier in Unit 6 and then some from Unit 5. So I'd like you to take a few minutes. You can do this with a partner or with yourself and answer these couple questions. And then once you've answered them, unpause the video so that you can see my answers. So first thing, what is a system of equations and what is a solution to a system of equations? So a system is 2 or more equations, and a solution to a system is their intersection point. Now again, you can pause this with this video and compare with your answers. Next is, how many solutions can a system of equations have? We can have 1 if the system crosses at an intersection point. We can have no solutions if the equations are parallel. Or we can have infinitely many solutions if the systems happen to be the same line. Again, pause and reflect on your answers. Number 3, how many ways are there to solve a system of equations? Well, we've learned 3 ways. One is graphing. 2 is substitution method. And our third method is elimination method. Again, pause and reflect on your answers there. Now, these questions here are all from Unit 5 when we did our inequalities unit. So what is an inequality? Well, an inequality has a less than or greater than, a less than or equal to, or greater than or equal to signs in it. So what would you think a system of inequalities would look like? So basically we are going to have shading that intersects. And we are going to have 2 or more inequalities, just like we did with systems of equations where we have 2 or more equations. Okay, well, all of the solving methods we stated work for a system of inequalities. Well, not really. So the methods that we talked about up here, these will find the intersection points I'm going to abbreviate that, but will not find the intersection of the shading. Therefore, we need graphing method. Okay, so how many solutions can a system of inequalities have? Well, we actually can't have 1 anymore. We can either have none or infinitely many. So I'm going to show you what that means when we get here. So we are going to solve the system of inequalities by looking at the graph. Now you can see that these are in slope-intercept form. So we're just going to go ahead and graph them. So this one has a y-intercept of 2 and a slope of 1, which means up 1, right 1. So I'm going to plot my points all the way across the grid, If you need to pause in order to do this, go ahead and pause. Now this has a greater than or equal to sign, which means it is a solid line. And greater than would mean our shading would go above. And this we talked about in Unit 5. Now for the second inequality, I had a y-intercept of -6. 1, 2, 3, 4, 5, 6. And a slope of -3/1, which is down 3, right 1. And take a minute and pause if you need to graph this. Now we have a less than symbol here, so that means we have a dotted line. Again, we talked about this in Unit 5. And we have a less than symbol, so we shade below the line. Now we do have an intersection point right here, but that's not technically part of our solution because we have a dotted line with crossing a solid line. Dotted lines are not included in the solution set. So this intersection point, even though it looks like an intersection point, it's actually technically an open circle. So I'm going to make that an open circle. Now you can see my shading here where it is all cross-hatched. This whole section here is actually my solutions. And if this graph continued and wasn't just cut off because it's a piece of paper, we would have infinitely many solutions here. This solid line is a part of it. This dotted line is a boundary for it, but not actually included. But if I picked any point here in this part of the system, that would be a solution. So I'm going to end this video now. This is part 1. Part 2 is going to show us how to do word problems for systems of inequalities, which is where actually our most usefulness comes out of this type of problem.